Assalamualaikum warahmatullahi wabarakatuh. So today we are going to present about our assignment, group project pair, probability and statistics. Chapter 2, probability. Counting sample point. In a medical study, patients are classified in 8 ways according to whether they have blood type AB+, AB-, A plus, A minus, B plus, B minus, O plus, and O minus. And also, according to whether their blood pressure is low, normal, and high. Find the number of ways in which a patient can be classified. Okay, firstly, draw a tree diagram. Since P for patient, L for low, and H for high, next, patients are classified in N1 equal to 8 ways according to their blood type. Then they can be classified in N2 equal to 3 ways according to their blood pressure. Next, according to rule 2.1 in page 45, in our case, first operation can be performed in N1 equal to 8 ways and the second operation can be performed in N2 equal to 3 ways. So the two operations can be performed together in 8 multiplied 3 equal to 24 possible ways.
Question 2.32. A. In how many ways can sick people be lined up to get on a bus? So the solution, firstly, according to the theorem 2.1 page 47, the number of permutations of n objects is n factorial. We substitute n equal to 6. So 6 factorial equal to 720 ways. Question B. If 3 specific persons among sick insist on following each other, how many ways are possible? So the solution, firstly observe these 3 specific persons as 1 person. Then we have 4 persons instead of 6 persons. According to rule 2.1, first operation is n1 equal to 4 factorial. Second operation is n2 equal to 3 factorial. So n1 multiply n2, there are 144 different ways for arrangement. Question C. If 2 specific persons among 6 refuse to follow each other, how many ways are possible? So the solution, we find out that the way 2 specific persons refuse to follow each other is with all possible ways. 6 people can be lined up minus ways 2 specific persons will follow each other. We provided that C factorial is all possible ways 6 people line up, and 5 factorial multiplied 2 factorial are ways 2 specific persons will follow each other. Hence, C factorial minus in bracket 5 factorial multiplied 2 factorial, we get 480 ways.
Conditional probability, independence, and the product rule. For married couples living in a certain suburb, the probability that the husband will vote on a bond referendum is 0.21. The probability that the wife will vote on a referendum is 0.28. And the probability that both of the husband and the wife will vote is 0.15. Question A. What is the probability that at least one member of a married couple will vote? We need to find probability with H union with W using inductive rule applied to union of events. The formula probability of H union with W equal to probability that of event H plus probability of event W minus probability of the intersection of H and W. So we calculate 0.21 plus 0.28 minus 0.15 and we will get 0.34.
B. A wife will vote given that her husband will vote. So the solution, we need to find probability of W given H according to the definition of the definition probability. The formula probability of W given H is equal to the probability of the intersection of H and W divided by the probability H. So we calculate 0.15 divided by 0.21, we can get 0.7143. Question C. a husband will vote given that his wife will not vote. So the solution, we need to find the probability of H given W prime. The formula, the probability of H given W prime is probability of the intersection of H and W prime divided by the probability of W prime. Firstly, probability of intersection H and W prime is probability of H minus the probability of intersection of H and W. We get 0.06. Second, the probability of W prime is 1 minus probability of W. So we get 0.72. Hence, we calculate the probability of H given W prime, we get 0.0833.
Chapter 3, Random Variables and Probability Distribution. Continuous Probability Distribution. The total number of hours measured in units of 100 hours, that a family runs a vacuum cleaner over a period of 1 year is a continuous random variable, x, that has the density function. Question A. Find the probability that over a period of 1 year, a family runs their vacuum cleaner. So, the solution is x is the total number of hours measured in units of 100 hours. We must find the probability that x is less than 1.2. Using formula 3 in definition 3.6, we need to integrate fx dx with limits 0 and 1.2. Next, we divide it into integrate x dx with limits 0 and 1 plus integrate 2 minus x with limits 1 and 1.2, and we will get the answer 0.68.
Question B. Between 50 and 100 hours. So the solution, we need to find the probability of x is greater than 0.5 and less than 1. Using formula 3 in definition 3.6, we calculate the integrate fx dx with limit 0.5 and 1, and it can be integrate x dx with limit 0.5 and 1, and the last answer is 0.375.
Chapter 4, Mathematical Expectation. Mean of a random variable. The hospitalization period in days for patients following treatment of a certain type of kidney disorder is a random variable y equal to x plus 4, where x has the density function. Okay, so the question is, find the average number of days that a person is hospitalized following treatment for this disorder. Firstly, we need to determine the expected value of the random variable y. Using definition 4.1, we can say that ey equal to ex plus 4. So we can find integrate x plus 4 multiply with limit 0 and infinity, and it can be x plus 4 multiplied by 32 divided to x plus 4 power of 3, and the final answer is 8.